Hey, sorry guys. Today we're going to get our solution to 2025 AB4 or BC4. So on the AP Calculus exams, both exams, if you took AB or BC, you would have seen this question. So earlier in FRQ3, we had the 2025 edition of the table question where you were supposed to use this table to approximate the derivative, the Riemann sum, and a bunch of stuff. And this time, we have the 2025 edition of the graph analysis question. So if you're not aware of what this is, they're going to give you a graph of a function. It's either a function or its derivative, and it's gonna if it's the function, it's gonna define an accumulation function, and you're going to have to find values for that function, its derivative or its second derivative, and analyze that function based on the graph that you have here. This kind of question comes up every year, just like the table question does. And it's very important you get these skills down because if you do that through the table and graph, that's 18 3 points whether you're taking A, B, or BC on the FRQ. Just letting you know that if you ever think about taking the AP Calculus exam. So, without further ado, let's get going on FRQ 4. Part A is very simple. Find g prime of 8 with reason. So with the reason, it's just going to be the fundamental theorem of calculus. G prime of x, g of x equals the integral from 6 to x of f of t dt. G prime of x would be f of x based by the fundamental theorem of calculus. So once you get that reason, you could say g prime of 8 equals f of 8 equals 1. If you can see from here where I'm pointing. Okay. Next up, we have part B, where we're going to have to determine points of inflection. So recall that points of inflection occur when the second derivative of a function changes sign. In this case, G, the graph of G has points of inflection when G double prime of x equals f prime of x changes sign, or or when f of x changes monotonicity. Increasingly decreasing or decreasingly increasing. Therefore, um, let's point out the monotonicity. F of x is decreasing from on negative 6 is from negative 6 to negative 3, the open interval, increasing on from negative 3 to 3, decreasing from 3 to 6, and increasing finally from 6 to 12. Therefore, f of x changes monotonicity at the points. I'll just check this. X coordinates of x equals negative 3, x equals 3, and x equals 6. So the graph of g of x would have points of inflection at x equals negative 3, x equals 3, and x equals 6. And these are answer for part B. In part C, we have to find two values for the accumulation function. So here we're just going to provide simple reasoning. G of 12 equals integral from 6 to 12 of G of d dt. And this would be 1/2. This is the area of a triangle, so 1/2 times 6 times 3 equals 9. And G of 0 would be integral from 6 to 0 of G of t dt equals the negative of the integral, the opposite of the integral from 0 to 6 of the function. And this would equal negative pi over 2, it's a semicircle. Gotta make this in parentheses just to be clear, times 3 squared equals negative 9 pi over 2. And let's label them. And part empty answer 2. And finally, in part D, we're going to determine the x coordinate at which the absolute minimum of G occurs. So here, we're going to have to find the critical points. So G of x has critical points when G prime of x equals f of x equals 0. Or when x equals 0 and x equals 6. So to find the absolute minimum G of x, perform a candidates test on G of x equals the integral from 0 to 6 to x of f of t dt. So we can get all of these geometrically. So here we're going to create a table and do a candidates test. So I'm going to create a table here. Just hold on a second, I need to find where it is. Oh yeah, table. I'm going to create a table for us to do a candidates test on the endpoints. So to do extrema, so here we have x, here we have G of x. So we have negative 12, our endpoint, no, negative 6 here. We have 0, 6, the critical points, and 12 on our endpoint. So at 6, because it's from 6 to x, 6 to 6, the integral would be 0 because of our integral property. At 0, that we already found our G of 0, this would be negative 9 pi over 2. And this area is the opposite of the area, so when you add these together, it cancels out, and this will also be 0. And we already discovered that this was 9 from our previous part. So this cell is our minimum value for G of x. So we do this and say, therefore, by the candidates test, the graph of G, we'll just say G of x attains an absolute minimum at x equals 0 on the interval negative 6 that is closed to x to 12. Part D answer. And that's it for the graph question. It's very similar to the past years. I know with the digital format you're not able to draw on the graph anymore, which is kind of sad because that kind of helped people, I think, when they were trying to find the errors. But at least the errors are pretty easy to find this time. So I'm guessing grind past graph questions. You have this one to grind to now, and expect to have to do something on the graph without annotating it now that the test is fully digital. Thanks.